guys, welcome to our video. My name is Muhammad Aiman bin Ibrahim from Bmma section 1/2. Today, me and my two members, Harley Jolison and Manoj Kumar, are going to present about our experiment that is torsional loading evaluation from actual structure. The product that we choose is flexible handle. As we can see, this is our poster. The content in this poster is introduction, objective structure and specification, calculation, discussion, and conclusion. Now, I want to tell you about intro of torsional loading. In the field of solid mechanics, torsion is the twisting of an object due to an applied torque. Torsional loading is a test that twists material to a specific degree with a specific force or until the material fails in torsion. In sections perpendicular to the torque axis, the resultant shear stress in this section is perpendicular to the radius. The objective of this experiment is to determine the behavior a material or test sample exhibits when twisted or under torsional forces. Second, to determine the FPD from flexible handle. Third, to determine the equation of equilibrium, yield shear strength, ultimate shear strength, and modulus of rupture in shear. Fourth, to find the maximum torsional force that will fail to the flexible handle. Lastly, to determine the factor of safety used in flexible handle. Next, I will pass to Harley Jolison to continue next part. Thank you.
Hello, my name is Harley Jolison. Today I will explain about the calculation. First, we should know about the structure of flexible handle. The structure specification is first material steel, alloy steel. Shear modulus G equal 80 GPS for steel, and length for the flexible handle is 350 mm, and the length for extension socket is 85 mm. For the diameter for extension socket is 16 mm. For the maximum torque for ball tightening a pulley crankshaft is 70 Newton meter and convert to 72 lbs and convert to Newton meter, which is 97.6 Newton meter. So this is the picture for the condition of tightening pulley. Next. So the first calculation is polar moment of inertia, which is J equal to pi over 2 times with C4. When diameter is 16 mm, J equal pi over 2 times with 0.008 power of 4, which is in millimeter, and the answer is 6.434 times 10 power of -9. The maximum shear stress is T equal TC over J. At T equal 10 power of 9 is for the shear modulus, and equal with T times with 0.008 over with 6.434 times 10 over 10 power of -9. So the final answer is 64.34 kilonewton meter. For the FPD, equation is moment equal with 0. So -70 is for the T max of extension socket, plus with F multiply with 0.35 equal with 0. So F equal 200 kilonewton meter. For the maximum torque for bolt tightening of pulley crankshaft is 97.6 Newton meter. The factor of safety Fs equal with Tmax over T actual, which is 70 kilonewton meter per 0.0976 kilonewton meter. So final answer is 7717. Thus the extension socket is safe in this condition for bolt tightening of pulley crankshaft. That's all from me.
Okay, guys. My name is Maurice Kumar, and I'm from Bmma 1/2, and I'm here about to discuss about the discussion. Before we get into the main discussion, first we learn about the calculation that we being used in this assignment. First of all, polar moment of inertia. It is a measure of an object's capacity to oppose or resist torsion when some amount of torque is applied to it on a specified axis. Next is the shear stress, uh, which is the torsion. In this case, shear stress is a torsion. It's nothing but the twisting of an object due to an applied force. Next is the factor of safety, or also known as FOS, safety factor, which is how much stronger a system is that it needs to be for an intended load. Okay, based on the calculation and the derivation made throughout this process, we're able to generate the polar moment of inertia, which is 6.434 times 10 to the power of -9. So through that, we're able to find the torque by using the shear stress formula, which is the result is 64.34 kilonewton meter. In this bolt tightening situation, we assume that the torque maximum, which is equals to 70 kilonewton meter, and the torque which is actual, which is needed for this situation, which is the bolt tightening, is 97.6 Newton meter. So from this, from the information we gathered, we're able to evaluate the factor of safety by dividing the maximum stress divided by the actual or working stress, which in this case the factor of safety is 717. So as a result, the extension socket is safe in this working condition. While selecting the factor of safety, we also consider the properties of material and the possible change of structure during operation. And finally, in conclusion, we can determine the properties of the tools that be used for bolt tightening at the desired torque requirement. Beside that, we are also able on how to apply the formula for polar moment of inertia in real situation with the real structures. We also know to use the formula of maximum shear stress for the torque. Lastly, we also know how to determine the factor of safety for the tool or the actual operation or using the actual structure that being used to ensure it is suitable at the working condition. And that's it from us. Thank you.